Today, we will try to give a quick introduction to object-oriented programming, a core concept in computer science, a one that you will face a lot of time, basically every day in your career as a software engineer. So without further ado, let's start by mentioning the four pillars of object-oriented programming. These will be our topics that we will talk about today. First, we will talk about encapsulation, second, abstraction, then inheritance, and lastly, we will talk about polymorphism. So let's start by remembering what we was doing before object-oriented programming. Mostly when you start learning programming, you got to learn what is called a procedure programming, where you got to open one file and write a very long code consisting of attributes and functions. And while you start to add more and more to this code, you get in the problem that every function you write impact a lot of functions you used before. Every function that change one attribute impact how the other functions work. This problem we needed to solve. Hence, there comes OOP, Object-Oriented Programming, to solve this problem for us. So what OOP have done that introduced a concept called encapsulation, where we get every methods and attributes related to each other and encapsulated it in one object, where we called these attributes property and the functions method. All of these attributes and all these property and method are related only to and are related to the object it encapsulates, and only for this object only. We can't access it from any other object. Let's take an example, like car. A car would have attributes or properties like make, model, color, and have functions like start, stop, and move. But we don't have a car in our program, so let's give a more reliable example, something that you will face every day. If you try to open your browser and open the inspect mode, and we start by writing local storage, every browser have a local storage. We can find an object called storage inside it, which have a property length and some functions like set item and remove item. Let's take a code example. We start by writing a procedure code. We have here three attributes: base salary, overtime, and rate, and a function getWage that have three parameters passed to it: base salary, overtime, and rate, and it return this equation. Let's see what if you want to write it in OOP, what will it look like. So here we created an object called employee with a base salary, overtime, and rate property, and this object have a function called getWage that doesn't have any attribute inside it, and it returns basically the same equation as before. As we see outside, what we want to do is call employee.getWage to access the function getWage from the employee object. This is perfect example of OOP. It removed our overhead from using a parameters in the getWage, and like Uncle Bob said, the best functions are those with no parameter. Second concept we will talk about is abstraction. Abstraction means that we can, for this object, hide some properties and methods that nobody can access except from inside this object. This will give us a simpler interface. So if we have an object, it will only have two public functions that are very validated and very good to interface with this object, and it will solve the problem we faced before of impact of change of functions on each other, because the properties and functions are encapsulated inside this object. Third concept we'll talk about is inheritance. So let's start with a quick example. Let's say we have a web application, and in this web application we have three elements: textbox, select, and checkbox. As we can see, we could have many properties that are common between the three, like if hidden, which represent if it's hidden or not, the inner HTML, and it's the code for each element of them. And we have a common methods like click and focus. So what inheritance provide us, that we can create an parent class, an upper class, for example, called HTML element, and put these common properties and methods inside it. And we inherit for each class from the parent class. This reduces the redundancy in our code and provide us with a cleaner and a simpler code to use. Last topic we'll talk about will be polymorphism. Poly stands for many and morph for form. So polymorphism means many forms. Let's start by giving a quick example. A switch case. As we see in the previous example, we have a select, text, and checkbox. We want to render each and every one of them. So a basic code to render this is using a switch case, where if the case is select, we render select, it's text, we render text, and so on. But is there any cleaner way to write this code? Yes, there is, by using polymorphism. What we can do is, inside HTML element, we write an abstract function called render, and for each child of this parent, textbox, select, and checkbox, we write a different implementation for this render method. So now if we want to render any of them, all we need to do is write element.render. It's simple and easy as this. Finally, let's recap what we have learned in this video. We talked about the 4 pillars of object-oriented programming and the benefits of each of them. We started by encapsulation, and we found that it reduced complexity and increased reusability of code by encapsulating methods and properties for each object inside this object only. Second, we talk about abstraction and how it reduces complexity and isolates the impact of change of each method on other methods that help us not to change every function that is connected to a function. We change only one line in it. Third, we talked about inheritance and how it eliminates redundant code by getting common attributes and common methods inside one parent class and inherit from this class. Finally, we talk about polymorphism and how it can refactor ugly switch case statement by implementing a different implementation for a parent method inside every and each one of the children. That was our video for today, and I'm open for any questions. Thank you.